Okay, so today, what we want to do is talk about, we're going to calculate, interpret average rate of change, which is actually pretty easy. It really is. So, Common Core, calculate and interpret average rate of change. So, what we want to do is first, number one, we're going to look at this table below, and we're going to create a scatter plot, okay? So, I'm just going to get my graph paper out. Time, I'm going to go from 8 a.m. to 7 p.m. I'm going to be a little careful with this. I'm going to have to probably work with some military time. So when I hit 1 o'clock, I'm really going to call it 13. Does that make sense? So when I go across my axis, I don't go from 12 to 1. That really won't work for me. But I'll have to call out like a 13 and a 14, a 15, a 16, 17, 18, 19. So when I graph the whole thing, it's going to fit. So on my scatter plot, let's see here, I need to go across from 8 to 19, so, right. And I'll start at 8 o'clock. I'll let 8 o'clock be where the axis is. 8, 9, 10, 11, 12. 1 o'clock is going to, we're just going to 13, we know that's 1 o'clock. 14 is 2 o'clock. 15 is 3, 16 is 4, 17 is 5, 18 is going to be 6, 19 is going to be 7. I think that's all the further I have to go to 7 p.m., okay? p.m. So, I mean, it doesn't make any sense on any number line to go from 12 to 1, right? You can't really go 9, 10, 11, 12, 1. No. It's all because we're going from AM to PM, so instead I just went 13, 14, 15. But I put the PM numbers down below on my axis so you can see it. Now these go all the way up to like 60, so let's see, if I just go by tens, 10, 20, 30, 40, 50, 60, and I'm just going to put the dots as close as I can, alright? So at 8 a.m. I need to go to 38, it's about there, right? Am I going too fast? Can we slow down? Am I okay? Alright. 9 o'clock is at 40. 10 o'clock is at 44. About there. 11 o'clock is about 50. Noon is 56. It's warming up. 62 at 1 o'clock, which we call 1300. So 62 is about there. 2 o'clock, 66, about there. 67. 64 will start dropping because the sun's going to start going down, I suppose. 64. 58. 55, 51. I think I got it all, okay? Alright. Might as well try and sketch a curve through them best I can, alright? Alright. So by making the scatter plot, we can see it, right? It's better than just looking at a chart. When you look at a whole chart of numbers, you know, it doesn't really tell you. You could look at it carefully, but you look at the graph and say, oh, boom, highest temperature's right there. You guys agree? The graph makes it easy to interpret. That's why I like to do graphs, all right? So let's take a look at the first couple of questions, okay? First of all, find the average rate of change during these intervals, okay, from 8 to 9. So from 8 to 9, let me see. 8 to 9 is right there. Now, average rate of change, we had in our notes, it's going to be f of x2 minus f of, I'll put it up here. Never mind, let me erase that and put it up here. So I have room to do my work. F of x2 minus f of x1 divided by x2 minus x1, okay? So, in our problem, we don't have anything like x's or f of x's. We just have temperature and time. So, the time is really along my graph. The time is really the x's, right? These are my x's, and the temperatures are my y's. So we can think of the times as being the x's and the temperatures as being the f of x's, okay? Does that make sense? These are my x values and these are my y values. I know that from my scatter plot. So from 8 to 9, we need to go, it's 40 minus 38. It's just easy. 40 minus 38 over 9 minus 8. So I took its y value minus y value over its x minus x, and we get 2 over 1, which means basically it rose by 2 degrees during that interval.
So maybe it's 38.
Yeah, it is 38. Yeah. Okay, from 1 to 3, let's see. 1 to 3 is 1, 2, 3. All right. So we're going to do the same thing. We'll take our 67 minus our 62, right? With 67 minus 62 over my 3 minus 1, or even our 15 minus our 13, right? Same thing. It's just a 2-hour interval, that's all. So I get 5 over 2, which is about 2.5 degrees. Okay, what does this tell me? It tells me that it's growing at a faster rate. The temperature is growing at a faster rate from 1 to 2. Sun's out. It's getting sunny and warm, right? It's heating up more quickly. Does that make sense? Okay. Now from 4 to 7, the same thing. From 4 to 7 is this interval. So we'll go 51 minus 64 over my 7 minus 4. Okay. Oh, it's 51 minus, 51 minus 64, negative 13 over 3, which is negative, what's that, 4 1/3 degrees. Negative makes sense. Negative answer makes sense because the temperature is dropping. Everybody agree? Negative totally makes sense. And it's dropping rapidly because we know, living here in Leavenworth, is once that sun goes behind that mountain, it gets cold fast, doesn't it? Right? Okay, and that's why that rate, these are all rates. These are all rates. 2 degrees per hour, 2.5 degrees per hour, negative 4.333 degrees per hour, okay? All right, example 2. Find the net change. Well, in our reading, we found that net change was just simply f of x2 minus f of x1, okay? That was our net change. We're not going to divide. We're just going to say how much did it increase or decrease by. That's all. So to do it, we're going to plug in 3. Here's x1, x2, because it's an interval. We're going from 1 to 3. So we'll plug in our 3 first. So we'll go f of 3 is going to equal, let's see, it's a parentheses 3 minus 3 squared, right? Just plug 3 into the function. 0, right? And then let's plug in 1. So let's find out what f of 1 is. So plug in the 1. We'll go 1 minus 3 squared, which is negative 2 squared, which is 4, right? So the net change went from 0 to 4. From 0 to 4. So the net change is negative 4. So in this case, this graph is dropping 4, okay? Well, all right, let's take a look at it. I'm just curious. If I looked at the graph, maybe I could see why that is so. I like looking at graphs because it tells me something. So if I type in the parentheses x minus 3, right? Graph that, oh, forgot the square. My bad. Squared. Let's graph it. Okay, so look at the calculator, look at the graph. So from 1, here's the value of 1, to 3 it does drop, doesn't it? So the negative makes sense. It dropped from here to here, dropped 4 units down. There's my net change, okay? From 4 to 7, well, my guess is probably from 4 to 7 it's going to be positive. You can see it, right? It's going to be positive. So let's take then f of 7 minus f of 4, because that's really what the formula says. I don't need to do it in 2 steps. I can do it all in 1 step. F of 7, plug in the 7. F of 4, plug in the 4. So I would have a 7 minus 3 squared, because I plugged the 7 in, yes, minus my 4, which is going to be my 4 minus 3 squared. So 4 squared is 16, you're right, Alondra, minus 1, which is 15, right? So from 1 to 3 it dropped 4, but from 4 to 7 it raised itself 15. In fact, if we look at the graph, it makes sense. We're going down in the first interval. Second interval, we're going up by quite a bit, okay? Easy? Thumbs up? Okay, that's not bad, okay? Okay, turn the page. Okay, all right, now, so an object is dropped off a cliff and its distance t seconds later is modeled by the function 16t squared, okay? Find the average speed from 1 to 2 seconds. So we do the same thing. Now, it does talk about average. So we're going to divide. We're going to do our f of x2 minus f of x1 divided by x2 minus x1. When you see the word average, you need to divide, okay? When you see the word average, you need to divide. Just like anything, when you take an average, what do? You add them up and you divide, right? Any average, you add them up and you divide, okay? So when you see average, make sure you divide. If it's net, you don't divide, okay? The net is how much did it go up, how much did it go down. You don't divide. Easy? Okay? So let's do this one. So I'm going to take my 2, and I'll go d of 2 minus d of 1 divided by 2 minus 1. That's what I'm going to do. Plug in the 2, I'm going to plug in the 1, and then divide by 2 minus 1. So I'm going to go a 16 times 2 squared minus a 16 times 1 squared over 1. 2 minus 1 is 1, right? I think that's 64. 2 squared is 4. 4 times 16 I think is 64. Minus 16, which I think is 32, isn't it? 64 minus 16 is 48. I was wrong. Good thing I used a calculator. So 48, and that's in terms of feet per second, because it's going. It's falling. Okay. B. Okay. A and A plus H. Okay, so this is what Newton did. Elaine, you asked a really good question. This is right here what Newton did. Okay, so let's do this problem and then I'll explain what Newton saw in this whole thing. Okay, so first of all, we're going to give our 16 times our A plus H squared minus 16 times A squared all over A plus H minus H, okay? I'm going to set you up and I'm going to show you a picture. You guys are going to see what Newton saw. To me, I know I'm a math nerd. Yes, I am. Loser. I know, big loser. Anyway, when I figured this out when I was in college, I was like, you got to be kidding. Amazing thing. So check it out. Something is falling off a cliff, okay? We all know that as it falls, it goes faster and faster and faster and faster. So you can't just say that the speed of this thing is 32 because it's going faster, right? And faster. We could get an average speed, so we could say, okay, let's go T1 to T2, but that would just be an average, right? So what we do is when we do this T1, T2, if the T2 time gets closer and closer and closer and closer to the T1 time, my average speed, the error between my average speed gets less and less and less and less until the 2 points are almost on top of each other, right? So what we do is we say, let's let this distance between the time 1 to time 2, have this value h. And what h is could be 1 second, could be 2 seconds, but how much time happened before time 1 and time 2? Okay, let's make it shorter. Time 1 and time 2. Make the distance shorter between time 1 and time 2. So what we're going to do is, in a sense, make h disappear. When h becomes 0, the 2 points are on top of each other, and you get instantaneous velocity, or instantaneous rate, okay? So anyway, if you take physics, you're going to learn this. If you take calculus, you'll definitely learn this. So let's set this problem up, okay? All right, what we learned a couple of days ago when I foiled this, right, I learned when I foiled this, it turned out to be a squared plus 2ah plus a squared. Okay, I made you do that problem a couple of days ago on purpose. So I could, and it is h squared. Thanks, Marie. It is h squared. Okay, good thing I did it a couple of days too, huh? Minus 16a squared all over. What happens to the h's here?
They can cancel.
Right, they cancel and you just left with a, right? Everybody agree with that? How am I doing so far? Okay. If I distribute, I'm going to get a 16a squared plus a 32ah plus a 16h squared minus a 16a squared all over a. How am I doing? Yeah, the cancel. Remember we talked about that everything on this back side will always cancel. Okay, so then if I common factor out an h, I'll have an h times a 32a plus a 16h over my a. Something goofed up here.
You would factor out an a.
Factor out an a, not an h. Something didn't. Even on camera, I hate it when that happens. H should have factored out an h. A. Oh, I know what I did wrong. Way up here. A plus h minus a. The a's cancel. I'm just left with an h here. There's my mistake. All right. I knew I made a mistake. Cancel, cancel. I get a 32 plus a 16h. 32a. Alright, so I messed this up so bad. I made a mistake right there, okay? Now, can't see it. You want me to go through it one more time? No? No? Yes? Let me do it one more time, and I'll do it on a separate sheet of paper. Sorry I messed up so bad. So I've got between a comma a plus h, and I've got a 16t squared. So I'm going to go 16 times my a plus h squared minus 16a squared all over a plus h minus a. Okay, there's my mistake. I wrote an h there. My bad. That cancels that, right? This will FOIL into a squared plus a 2ah plus an h squared minus a 16a squared all over h. How am I doing, Will? Better? Okay, distribute. 16a squared plus a 32ah plus a 16h squared minus a 16a squared all over h. Am I doing better? Cancel, cancel, right? What do these two things have in common? An h. Take out an h. 32a plus 16h over h. That cancels, and there's my answer. Okay. Now, if this were time, you could plug in a time and it'll tell you what the velocity is at any particular moment. And that's what you're going to learn in physics. Okay, lastly, almost done. Okay, you ready? Almost done. Okay, now, right off the bat, the last question. I don't have to do any work. I don't have to do any work. What's the answer to A and B? What's the answer to both A and B?
The two answers of that.
It's 3. We could do the work. You could do the work. But what do we say? That the average change for a linear function is always the slope. There it is. Nice, huh? That makes up for that ugly bad one I just messed up on, huh? Okay, let me go ahead and stop recording.